So this session will be on leveraging 400 gigabit Ethernet to improve network economics while driving performance, presented by JJ. So JJ, if you can introduce yourself.
Cool. Thank you. Hi, my name is JJ Jamison. I'm the CTO for R&E Markets at Juniper Networks. I'm going to give this talk. Throughout it, you'll see like little stars, asterisks on things and things in red, and that's kind of reminders to myself to add something that's not on the slide. And so the thing I start off here with the stars to let you know that I'm not the original speaker that we intended to have up here. So there's a product line manager at Juniper named Venkat Janard Hannon. He had a personal issue that came up that he couldn't get out of, so he wasn't able to make it, and we apologize for that. He's a really sharp guy. He's an expert on 400 gigabit Ethernet, and he lives and breathes its applications in data centers. So instead, I'm your substitute speaker, and instead of trying to give his talk, I basically put my own twist on it. There was a lot of material that I wouldn't have given the same attention to or a quality of presentation, I think, as Venkat would have. But I'm going to bring to it some perspective from the R&E community, which I've been working in for maybe 25 years now. And I think it'll be interesting. I'm looking forward to hearing it myself, actually, because this is the first time I've given it, and it should be good. I'm going to have to watch my time, but we'll go to it now. So here's the first chart, and this is kind of at the bottom you'll see years, and on the side you'll see link speeds, and it's sort of a logarithmic scale. So the points that I took out of it weren't that obvious. The first is, if you'll notice, it's going from 10 to 100 to GbE to 10 GbE to 100 GbE. These are all factors of 10, so it's kind of a natural progression. Now we're going to 400 GbE. That's a multiple of 4. It sort of reminds me of the way Sonnet used to go up. And so that's the first kind of takeaway, that things are changing. And where you see futures, we've got 800 gig or 1.6 terabits, and those are multiples of 4, or like 2 times 4, 4 times 4, right? The other thing that might not be obvious on this chart is there's a bunch of stuff that are not on the line. And so what you see here is standards that were put out and they didn't get adapted kind of at scale, or at least not in the carrier market. And so the bottom stuff mostly ended up like on NICs for servers. The 200 GbE is being used in data centers for switches, but by a particular class of customers. So it's mostly like really massive social media customers. There's some uptake there. But otherwise, we're not seeing a lot of either sales or interest in that. But 400 GbE is going. So what are the drivers for 400 gig? And before talking about the drivers for 400 gig, we should pause a moment, or I'd like to pause a moment and talk about what are the drivers for Juniper Networks solutions for the R&E customers, right? And the solutions that we position, and I go around evangelizing, the drivers for that are actually coming from other markets. And it's not that we don't want to sell this stuff to you guys. It's like the big money is kind of calls the tune, right? And this is what they're looking for. And all the stuff that I think has worked really well in R&E networks and kind of helped us gain market share is things on this list, but they were driven by other markets. So in the beginning, it was like everything we were talking about was like we're fast, we're reliable, we're low cost, and we're still saying that. That was all done for carriers. And the way we pitched it was, oh, our software is better, we're building it on top of Unix. And that was true. And we also said we've separated the control plane from the data plane. And that was true too. But what that did was enable us to make things fast and more reliable. So that was really the differentiator. And the low cost came from competition. And I'm a strong believer that competitive market is the best one for everybody, for vendors and for customers. IPv6, we did for carriers. I was putting in request for IPv6 features. Sprint asked for it, and it happened overnight. Multicast was basically done for Wall Street, although it was widely deployed with our R&E customers. That's who wanted it. It was about getting trading data to people at the same time, and they needed to be fair, and there were some legal ramifications if they weren't able to do that. Some of the newer stuff that I've been evangelizing lately are express path on firewalls, and that's basically the ability to take elephant flows through firewalls at line speed, through the firewall, not around it. That was developed for Wall Street. Perf Sonar, which you can also call the third-party app, being able to run that on routers and switches, that was done for social media. Facebook wanted to run an app on our router, so we developed that capability. But now we're able to put apps in Docker on our platforms. And so we're working with the University of Michigan to get Perf Sonar on there. And then node slicing and R&E peering points, we did that for Verizon and Telefonica, but there's a bunch of applications that fit into our market. So we're going to go. So what's driving 400 gig E uptake in data centers? Oh, sorry. Here's the red. I played a little trick and apparently got it myself. So here's all these things, kind of old stuff, new solutions. 400 gig E for R&E networks, it's being driven by data centers. And that's a driver of it. So what trends are driving 400 gig E interest and uptake in data centers? And so you can read the slide for yourself, and I'm sure they'll be available online, but the things that stood out to me were there's so many more devices on the internet, and they're all putting out data. From the thermostat in my house now, it's ridiculous, right? So that's putting data, and that seems like hardly any data, but you start summing that, and if it has to go somewhere and be processed, it creates a load when you add it to millions of other tiny flows, right? Businesses are transforming, and they do everything online. So if anyone's gotten here a paper paycheck recently, it was because it was your last one, probably, you know, and you were changing jobs. But everything's online, and from selling things to people to back office stuff to advertising, it's all going online, and that adds data. And then the data center application requirements of hyperscalers. So these are organizations like Facebook or Amazon or these search engines, you know, starting with Google, and then the other ones I'm not as familiar with, but this is a global presentation. But the big thing, and I highlighted this in red and made it bold and made it bigger for a reason, the thing that surprised me is that Del Oro Research forecasted that in 2020, which is next year, which, like Jeff, I find hard to believe, 20% of data center switching revenue is going to be 400 gig. And so this stuff is going to come out fast. I mean, it's coming. It's starting to come already, but it's going to be, the adoption of it is going to be way faster than 100 gig was. So what's driving 400 gig in R&E? And so the answer are elephant flows, massive instruments dumping ridiculous amounts of data when the preference is not to process that data locally. So I have a twin brother. He's not an engineer, but he's a pretty smart guy. And a couple of years ago, he's asking me, "Hey JJ, what's new at work?" So I'll tell him, "Oh, I'm so excited. I'm supporting these new customers. It's Department of Energy. They're running multiple 100 gig links across the ocean to this big particle accelerator in CERN, and they're doing like supporting all this new science, and we're putting state-of-the-art network, and no one's ever done that before." And so his question to me was, why didn't they, I said, the data, he goes, why's the data got to move? And I said, it has to move from the instrument to the computers that are processing the data. So he asked me, you know, why don't they just put the computers next to the particle accelerator? And, you know, because I was excited about networking, I hadn't thought about this. And the answer is, you know, it's sort of a complicated answer, but what my view is, this is an international project. The United States and other countries involved are not going to build supercomputers and put them in Switzerland or France, right? And also the scientists are local. Those they get used for other things. They drive the local economy. They drive the national economy. So there's reasons networks get used to move data other than, what you might take for granted, like it had to move. Another example might be the telescopes, the large instruments in in Chile and Hawaii, in a mountaintop in Chile, it's not practical to put a supercomputer up there. So you want to move data. But other newer drivers are there's new applications, and I was this week talking to both Eli Dart and Mark Foster about it. There's some machine at Slack that's dumping ridiculous amounts of data that they have to figure out how to boil down before they can send it anywhere. And they don't have the budget to process it locally. And there's supercomputers all over the country with cycles to spare, so they move it, right? And that's kind of what's driving R&E need for 400 gig. There's all the science DMZs and data transfer nodes. And there's an expectation of more elephants and bigger elephants. Because if you can have a 400 gig WAN port, someone's going to build a NIC, right? Maybe not today, but it'll happen. So these elephants are getting bigger. So what are the economics of 400 gig BE? And I'm just going to check with Robert. How many, are we like a third through now, Robert? Okay, so halfway. So I'm going to speed up. This gets to the good stuff. So with optics, the economies of scales are not compelling. They're not that compelling. So when you look at what we do at Juniper is we sell historically third-party transceivers on all our equipment. Thank you. And so if you bought 400 gig from us now, and I think you can, this is all kind of all brand new, it would be a third-party transceiver. So when we demoed it at Supercomputing, I'm going to talk about that at the end, it was a third-party transceiver. So the economy of scale, it's not that compelling because these manufacturers rely on volume to drive down cost. Unlike silicon, there's all these other things that basically give us Moore's law that make things cheaper, faster, and it seems like it's more and more a fact that we're able to do more and more for cheaper and cheaper, right? And in the optical field, hasn't been the fact. So Juniper's been successful in lowering the cost per bit that goes through our boxes by taking advantage of Moore's law, but we haven't been able to do that with our optical interconnects because we buy them from other people and they don't have this Moore's law working for them. So we bought a company called Orion in 2016, and that was to build in-house silicon photonics technology. So why is this important and what's our differentiators? And it gives us the ability to amplify or generate light on a chip, right? So we're not doing it, we're being able to take advantage of the silicon. And because we can use, put some of our packet processing or packet technology and the optics on a single die, the costs go way down for us, right? And so here's a picture of what it looks like. And so it's kind of cool. So the very left picture is what's called an opto ASIC. So it's a custom-made Juniper ASIC with an optical component to it. Then you'll see it, and it's a little confusing because they changed the center color of that little chip cap from pink to gold, but it gets moved over, and it's sitting on a transceiver package. And it's surface mounted right there. Then optics are connected straight to the chip, and you see the little fibers, and then they put it in standard QSFP module, and you plug these in. So although we don't sell these today, we are using them internally, and they're being qualified for future use. So here's like the meat, like the best slide in the whole deck. Our opto ASIC, it's fully integrated. We can put all this stuff on one chip at a low cost, right? And so then we can start making things cheaper because we're not buying it from someone else. But the kind of the future where this goes if when you combine it with what's going on in the packet forwarding engine. So the PFE, the packet forwarding engine, where the decisions get made of where to send the packet out, which port. We've been improving that because of Moore's law over and over. But we're running into Shannons Law, and I had to actually go look this up because I remember learning about it in school, but I wanted to make sure I knew what I was talking about. And so Shannons Law defines the theoretical maximum at which error-free digits can be transmitted over a bandwidth-limited channel in the presence of noise. So to translate into plain English, if you're trying to get data off a chip electrically, there's a limit, and we're hitting a wall that way. But if you can put optics on the same chip, then your limit is the speed of the optical path, right? And so that really makes a lot of different things possible. So although that picture, that little sort of baby picture there, that showed you that we were going to build this chip into a transceiver, where this is getting to be really powerful, and when we're going to, I think, really see a fundamental difference in the way routers are built, is when you can run those fibers all the way back to the packet forwarding engine. So if you can imagine, you're getting like a Moore's Law improved packet forwarding engine, and it's got all these fibers hanging off of it that go to the front, and then you plug into them standardly. That's a game changer, and it's very exciting. So quick cleanup, and we got like 10 minutes, Robert? Or? Beautiful, thank you. What's going on in R&E so far with 400 gig? We did a demo at Supercomputing 18, and we're working with Internet 2 and Learn on this, and these guys were great, and also the people at CENIC. And we basically, there's an Internet 2 MX960 at 400 South Ackerd Street. It's basically a point of presence. It's about a mile away from the convention center in Dallas. We ran 4x100 out of there to a PTX 103 that had a 400 GbE interface in it using someone else's transceiver that we bought, over to a QFX 10003 that also had a 400 gig interface in it. And then we striped out to the MX 10008 that was one of the core routers in CENIC. And this worked. And it was really exciting to see it. And this is why I enjoy working at Supercomputing so much at the show, because you get to do stuff like that you'd never do at home. So there was a guy that came from engineering to come and deploy this. And I told him I was really excited to see live traffic at 400 gig. And he said he was too. So it was like, we'd done tester stuff. We'd done stuff using testers like Spirent testers at OFC and demoed 400 gig, but no one had ever run live traffic over it. And so the great thing about working at Supercomputing is you get to do that, and you get to do it with other vendors too. So here's kind of like, this looks, it's hard to see, but if you kind of go to the middle and up, you'll see a bunch of Juniper boxes, and kind of this demo I was discussing is the left-hand chain there. And we successfully did it. It was the first time in the world that live production traffic moved over routers on their way to a wide area network. So what's been happening this year? We've had account teams and product line managers talking to R&E customers about doing 400 gig in 2019. So we've had conversations with a major supercomputing center, with a couple of research universities planning on upgrading their WAN access to 400 gig, to research universities planning, at least putting in proposals for 400 gig connected science DMZs. They put in CC star proposals. And we've also had early 400 gig planning conversations with several R&E network providers. So 400 gig is coming to R&E networks this year. It's not like a future, that is real. And that's pretty exciting. And we have a new demo planned for SE19 in Denver. And I have to qualify this because this is a drawing that I made after a conversation I had over beers with J.P. Velders of the University of Amsterdam and Mark Lyonnaise of Siena. So I might not have gotten things right. And also, the people involved, like Indiana University, might not know about this yet. But I'm sure they'll be open to it because they like to do new stuff. And so basically what we've got is 8x100 gig going from their MX960 to a PTX 10003. Remember that from last year demo. 2x400 gig going into a Siena Wave server. They've got this 1x800 gig DWDM channel that's going to go over 1,000 miles, not 1 mile. And then do another Siena Wave server breakout like that. And I'm fully confident we'll be able to do that. We'll have no problem getting parts and interfaces, and it'll be cool. So we're to the end, and I think we might have time for a few questions. Okay, cool. Thank you. So as an incentive to ask questions, I have Juniper Blinky balls. Let's see if we can get them to work. Right? So it's like an optical product. And if you ask a question, I'll throw this ball at you, and I might get somewhere near you. So does anyone have any questions?
Yeah.
Oh, there we go. Oh, Eli.
Yeah, Eli Dart, ESNet. Thanks, JJ. So I saw the on your last slide there. I'm just curious why not put the 400 gig in the MX? Are we planning to have 400 gig interfaces for MX routers by SC19?
Yes. So that's a good addition, Eli. We are, and then we could get rid of that PTX 10,003.
I mean, I don't want to get rid of the PTX. I just want to add the MX to it.
Yeah, no. I mean, that's a beautiful addition to the slide. Next time I give this talk, it'll be modified. So yeah, we definitely want to do that.
The virtual beer napkin, I guess. Yeah. Okay.
So do you want a ball?
No, thanks. I'm blinky enough as it is.
Okay. I'll give it to you later. So that might have been embarrassing, at least for me. Can I answer any other questions? Oh, cool.
Button. Talk like this. There we go. It wasn't a question, it's more of a comment and encouragement. The part about the allowing third-party software to run on the router itself, even as a container, logging off that way, I think that's neat, and to encourage that. I'm so used to being like, no, this is an appliance, you're locked out, this is the little dinky menu interface, you get to that. And yeah, when I have worked with Juniper, yes, you can shell in, you have an actual Linux command prompt. And so it's nice that it's being supported. It's like, no, you want to run software right on that router, then I thought that was neat. And so I was
Thank you.
Yeah.
And so I appreciate the comment, but I'll qualify it that, so it is open. We're working with the University of Michigan to get Persona running. We're not sure like what the performance is going to be. That's kind of why it's a research project. And the other thing is none of this stuff is supported. And so what does that mean? It means it'll run, it'll work. If you call the TAC, they'll ask you, what are you talking about? But it's open. Oh.
I will talk there. Even that still, you're not locked out. It'll be like you're on your own, but this is the path you can take if you want to go out into the weeds on your own. And yeah, that's still helpful.
And not totally on their own. Systems engineers that work with different universities can help. We can bring in other resources, but the regular support mechanism, which is the TAC, doesn't support this.
Okay, thank you.
You bet. Wow. Eli, you're going to get 2 balls now.
So, I actually have a bunch of questions. I just don't want to monopolize the time. So I realize this is very much in the future and still in development, but
not that much. They're using these things internally. So connecting straight to the PFE is a future.
That's what I was going to ask. Yeah. So I was really intrigued by that. So you're talking about petabit boxes. How far out is that? Is it 2 years, 10 years? Where are we at?
So I asked that question of Venkat just before I came up here, and it's the roadmap. The roadmap is vague, right? So they're really working at it. They see it as the future's kind of center of our architecture, but nobody knows yet. The transceivers, the pluggables, we have them. They're being qualified. You'll be able to buy them, but it's running glass to the PFEs. I've heard from customers that they've seen our CTO hold one in his hand with all these fibers coming out of it, but I haven't.
Okay.
So it's
okay.
It's definitely in the works.
All right. So prototypes exist.
Yes.
Which is fantastic. Okay. Anyone else, or can I monopolize it more? Okay.
What's the PCIe link between the control plane of the switch connected to the chip, so that you can have enough bandwidth for the Persona or any other kind of applications?
Yeah, so here's the I guess the qualification. If Venkat was here and we had our original speaker, he'd be able to answer that question. But I apologize, I don't know. But we can find out.
So I was chatting with our engineering group on Slack, and they were sort of surprised to see some of not surprised. They want to know more about the multicast application for Wall Street. So it's probably not the way we would deploy it, where we had historically deployed it in RNE, right? Which is sort of interdomain multicast with MSTP and all those kinds of things. But are you able to say what they're doing?
Only in that, I mean, I'm limited by lack of knowledge, but I can give you like a broad understanding the way I understood it went down. So there was like a really large company whose job it was to give stock prices to a really large audience. And so like you could guess who that might be.
Right.
And they couldn't do it like in a star and guarantee that anyone wouldn't be able to take advantage of it. Because, you know, these guys are nuts. If they can make a penny and multiply it by millions, they'll, off of a fraction of a second, they'll do it.
Yeah.
So that was the application. Multicast was involved. You know, we were always working on multipass. Greg Shepard was at Juniper for a long time.
Yep.
And he was a real champion of it. And we're getting it deployed in all these RNE networks. But the thing that drove it, like we can ask for like feature enhancements and stuff, but the money that came down behind it was this large Wall Street customer.
Thank you.
Right. So we're good for time? Cool.
I think this is exactly on time.
Excellent. So that's very good. So thank you all for your attention. I'll be great.